All right, today we're taking on linear relationships and we are graphing linear inequalities. So I have a couple instructions up at the top. So graphing an inequality starts by graphing the corresponding line. After graphing the line, there are two additional steps to remember. 1. Choose a point that's not on the line and see if it makes the inequality true. If the inequality is true, you will shade that side of the line. If it's false, you will shade the other side of the line. So for me, I always, if I can choose it, I would choose the origin, right? And sometimes I can't choose it if I have a line that slices through the origin. But if I get a choice otherwise, I would go with the origin. It's just a really good choice for a checkpoint. And then for 2, if the inequality is less than or equal to, so less than or equal to, or greater than or equal to, right here has a little dash underneath it, then the line part is solid. If the inequality is less than, so less than or greater than, so no dash underneath, then the line drawn is dashed. Okay, let's work through a few examples. So first up, so graph each linear inequality. So here I just have x is greater than or equal to 6. I don't see an x and a y, I only see one variable. And I know that when I graph an equation of x equals a constant, like that, it's a vertical line. Okay, so x equals a constant we'll graph as a vertical line. So x equals 6. I'm picturing x equals 6 first. So right here would be x equals 6 as a line. So now I need to picture, is that line part going to be dotted or solid? Since it's greater than or equal to, it has a little dash underneath it, it's going to be a solid line at x equals 6. All right, so a solid line at x equals 6. And then I have to figure out, well, which direction do I shade in? Well, this is a nice one. Since it's only the x is greater than or equal to 6, I can just go in the direction the arrow is pointing. I could also use a checkpoint. So if I use a checkpoint, again, I'm always going to use the origin if I can. So if I use 0, 0 as a checkpoint and I'm just plugging in 0 greater than or equal to 6, and that would be a false statement. Okay, which tells me that I'm getting a false statement right over here. So that means that the point here would not make this statement true. So anything in this region here would make this statement false, and anything in this region will make this statement true. So even if I wanted to double check, if I picked, say, this point right here, 9, 0, and plugged it in, 9 is obviously greater than 6. So this is the region that I shade. And what that means is that any point that's in this region will make this statement true. Anything in the opposite region over here will make that statement false. All right, my next one here, I have two variables. So this will graph as a line first as y equals 1/3 x. So I want to start with that. So how would I graph that as a line? So I have a y-intercept of 0. There's nothing attached here, so my y-intercept is 0. So I'm going to drop my anchor at the origin, and then my slope is 1/3. So up 1 and right 3. Up 1 and right 3. And then I know that it's less than, not equal to, so that line portion is dotted. And it's dotted because any point that would be on this line here would actually give me an equal statement here. And I can't have something equal to itself because I'm told that this is less than this value here. So I'm looking for that relationship. And since I slice through the origin right here, that's not a good checkpoint. So I would pick another number over here, 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 in any of those regions as your checkpoint. And since its y is less than 1/3 x, I already have a sense that it's going to be below. Since its y is less than, I think it's this region. I'm pretty positive. I'm just going to double check. So I'm going to pick, say I pick this point right here. That'll be my checkpoint, 6, 0. So if I get a true statement here, then that is where I shade. If I got a false statement, then I would shade the opposite region. So if I plug that in, I have 0 is less than 1/3 of 6. So is 0 less than 2? Absolutely, that is true. So I'm looking for the region where there was the 6, 0 right there, and I'm going to shade it. So any point then that falls in this region will make this statement true. Anything that falls in this region will make this statement false. Okay, let me slide it up. All right, so in C here, I see slope-intercept form again. Right, I can recognize y equals mx plus b. So I can see that my y-intercept would be at 0, 7, so right here. My slope is -2, so I'm going to go down 2 and right 1. Okay, it can be equal to, so the line part will be solid. And since it's in slope-intercept, since I have the y on the left-hand side, no other variable on the left-hand side with it, then I know that if I go anywhere on this line, I'm looking at less than or equal to. So anything that's below here, this should be my shaded region. So I know that right away, but I still like to use a checkpoint. So I'm going to plug in 0, 0 as the origin as my checkpoint. So again, if I plug that in and I get a true statement, that's the region that I shade. So plugging it in, I get 0 is less than or equal to -2 times 0 plus 7. So plugging in something with 1 0 or 2 zeros, it just wipes so many things away, makes it so easy for your checkpoint to see if it's true or false. So I get 0 is less than or equal to 7, right? Absolutely true. That is the region that we shade, the one that has the origin as one of the points. All right, the next one that we have, we see that it's in standard form. So I don't have only y on one side. I have both my variables on the left-hand side and my constant on the other. So I can picture this as ax plus by equals c. This is standard form. Standard form I like to graph using the intercepts. So I want to look for my x-intercept, which is when y is 0. And I want to look for my y-intercept, which is when x is 0. All right, so if I plug in a 0 for y, plug in a 0 right here and cover that up, x will be equal to 4. So as a point, that would be 4, 0. For my y-intercept, I plug in a 0 for the x. So plug in a 0 here, cover that up. And if I divide each side by 2, my y value is 2. So as a point, that would be 0, 2. So plot both points, 4, 0, 0, 2. Okay, and since it's not equal to, I don't see a dash, it gets a dotted line. Okay, and then to figure out which side I shade, I have to pick a test point. So here, again, I'm going to pick the origin if I have the luxury, so 0, 0. So if I plug in a 0, 0, right, it's going to make this whole side go away because I have 0 plus 2 times 0 greater than 4. So 0 greater than 4, well, that's not true, that's false. So that means that 0, 0 is not a solution that's in the shaded region. So this should stay unshaded. My shaded region should be up in here. And if you wanted to be further clear, you could always pick another test point. All right, 2 more. Okay, the next one here, I have point slope form. So I have y minus y1 equals m times x minus x1. So here, point slope form, I have a point. That point is at 3, negative 2. Remember, opposite of what it appears. So 3, negative 2 with a slope of 1/4. So I want to plot a point at 3, negative 2 right here. Go up 1 and right 4. Okay, and then here it's going to be dotted. It's not equal to, so a dotted line. Okay, and then the directionality that I shaded. So here, since I do have a y on the left, x is on the right, less than should be below it. So this should be my solution region, but I'm going to use a checkpoint to double check. So I'm going to pick the origin. Okay, and if I'm shading this region, I'm looking for a false statement when I plug in the origin, because everything in here should not be part of the solution region. So if I go ahead and plug in, I have 0 plus 2 is less than 1/4 of 0 minus 3. So is 2 less than 1/4 times negative 3 is negative 3/4. So is 2 less than something negative? Nope, that's false. So that means that this point right here is not in the solution region. This is not the shaded region. This is the shaded region. Okay, one last one. Here I have y is sandwiched between these two numbers. I only see a y. So this is essentially 2 horizontal lines. I'm looking at a horizontal line at y equals negative 4 and at y equals positive 7. So y equals 4, horizontal line right here, y equals negative 4 right there, and I can see that y is greater than or equal to negative 4. So it's going to be equal to, I can make it nice and solid. And at y equals 7, y is less than 7, that's going to be dotted. Okay, so the fact that I only had the y, that told me I was looking at horizontal line, or in this case, lines plural, which is always y equals a constant. Okay, so then here, this one is pretty nice because it's saying y is sandwiched between these two constraints. So it's y is sandwiched between the negative 4 and the 7, from here to here. So if it's the in-between region, then I just have to shade over in here. And let's say that I did pick a checkpoint, which I can always do. Let's say that I double checked it with the origin. So if I plug in a 0 right here, is 0 greater than or equal to negative 4 and at the same time less than 7? Yes, it is. Okay, so again, it just confirms, double checks that I shaded the correct region. All right, that's all I have for today. Have a good rest of your day.